In part B then, we're asked to explain why the inverse function does not exist when a is minus 10 and b is 10. So the function we're talking about now is this graph, yeah, the graph that we drew in part A. And I've redrawn the graph, okay, but I've looked at it sort of from a different scale, okay, but I've still got my minimum there, minus 3 and positive 4, right? But the point is then, I've concluded then the graph, so it's got the scale of minus 10 to 10, and that's what you need to appreciate here, isn't it? F of x, they've defined here with this domain 8ab, okay, so the domain is ab, which effectively is going from minus 10 to 10. So why can't the inverse function exist? Well, the issue is that we've got a many to one function here. If you think about it, from minus 10 to 10, it's many to one. In other words, I could choose a value here on the axis, okay, and if I was to look for an inverse function, we'd have a problem, wouldn't we? Because the inverse function wouldn't know where to go. It could either go to the right and give you this x value, okay, or it could go to the left and give you this x value. So it's got two choices to make, and we can't have that for a function. A function should only be doing one thing. So, you know, when you're opening the opportunity for it to have a choice, okay, when you're taking that value, so you either go one way or the other, it's no longer a function. So that's why it does not exist. Okay, so we could say the reason, okay, f inverse does not exist, okay, since f, the function f itself, is not one-to-one. So we state that and you get the mark. Okay, it's many to one. In fact, there are many solutions. In fact, there are two solutions for x here, yeah, that give you that solution for in f. So f is not one-to-one, so that means then f inverse does not exist. So in part 2 then, it says, write down a value of a and a value of b for which the inverse of f does exist and derive an expression for f inverse x. So here you've got a choice, right? There really is a choice through here. But you want to make the graph, you want to restrict the domain so it's one-to-one. Okay, it really is your choice. Now, of course, the key is this minimum value here, isn't it? That's where you've got to sort of have one end of your domain, quite simply. So then you could go, if you wanted to, all of this, the negative part of it, you could go minus 3 all the way to negative infinity. Or you could go from negative 3 all the way to positive infinity. Okay, so in fact, I'm going to take the negative root here, right? So I'm going to say, well, look, if we sort of take this part of the curve here instead and restrict the domain so that we have got one-to-one function for f, so that we've got minus 3, and then we look at the negative part of the curve along the x-axis there. So in terms of what I set my a and b to be, well, a and b, okay, will be set to, well, a can be anything you want, okay, it could be minus 10, because they let you make the choice. You could restrict it to wherever you want. You could even go to minus infinity. You could just keep it going, okay, and in the mark scheme, they accept that, so I'm going to let minus infinity be for a, and b then is going to be my upper limit, isn't it, which I'm going to set to be minus 3, okay. Now I can choose whether to include it or not, okay, and maybe I will include it, because it's my choice. I'm going to include it there. You don't have to include it. But having said that, let's just look closely here. They have got round brackets, haven't they, in fairness. Let's maybe double think that. Let's keep it as a round bracket, yeah. Okay, so then it says find the inverse function of f. Well, remember then, if you've got f of x equals to, what was it, x squared plus 6x plus 13. Now you've got to use the completed square version, okay, that we had earlier. Like that, okay. Take the 4 over. Okay. Then we've got a square root. Of course, when you square root, you've got to do plus or minus, haven't you? You've got to do plus or minus. Of course, now we're going to choose the negative, aren't we? We're going to choose the negative because we know in our domain that we've got up here, we've got our domain to be less than minus 3. Yeah, that's our domain here. X is less than minus 3, which means, I suppose, if I take that minus 3 over, x plus 3 is going to be less than 0. Yeah, we know this has got to be negative. We know it. Okay, so we'll say that take then the negative square root as such. So we get negative this And then to finish off, we say f to the minus 1 of x is equal to negative, put it in terms of x, okay, so negative x minus 4, and take that 3 over, so it goes minus 3, and we're done.